Yes, screen is visible, all of you.
Yes, sir.
Okay. Good afternoon to all of you. Uh, uh, Today we are going to discuss about the electric vehicle charger. Electric vehicle charger. And in previous lecture, what we have seen, what is electric vehicle and what is a conventional vehicle, what is difference between the conventional vehicles and electric vehicles, what are the parts of electric vehicle, and why we are going for the electric vehicles. Clear? Why we are going for the electric vehicles and components of electric vehicles. Okay, electrical motors, batteries, and converters. Okay, how the converter, what is the role of converter in the electric vehicles? Clear? How it will convert from AC to DC, DC to AC, and DC to DC, and so on, etc. We have seen previous lecture. Clear? So today we will one more part is one more component of the electrical vehicle is electric vehicle charger. Electric vehicle charger. Okay. Generally, everybody knows what is charger. Clear? A battery charger can allow unidirectional or bidirectional power flow at all power levels. Okay. The bidirectional power flows adds adds to the grid to the vehicle interaction, that is called as G to V, or also the vehicle to grid V to G. Clear? Means what we can say here, whatever we are using the charger in the electric vehicles, that charger can allow the bidirectional power flows as well as unidirectional power flows. Okay, in both ways it is possible. It will flows the power from vehicle to grid as well as grid to vehicle. It is clear. So generally there are two types of chargers. Generally there are two types of chargers: onboard chargers and off-board chargers. What is onboard chargers and what is off-board chargers? Onboard charger is nothing but batteries chargers can be implemented inside the vehicle, that is called as the onboard charger. Okay, onboard charge is nothing but the charger is placed inside the vehicle. The charger is permanently placed inside the vehicle. That charger can be called as the onboard chargers. Clear? Offboard charger is nothing but offboard charger is nothing but the charger is not placed inside the car, inside the vehicle. Okay, the charger is not placed inside the electric vehicle. Okay, we are using the additional, we are using the outside of the vehicle. Okay, that type of chargers can be called as a off-board chargers. Off-board chargers. So फॉर एग्जांपल आउटबोर्ड चार्जर्स के लिए अपना मोबाइल का चार्जर बोल सकते ना. कैन वी टेक एज एग्जांपल ऑफ आउटबोर्ड चार्जर्स, मोबाइल चार्जर.
Yes, sir.
Okay, because battery is placed inside the mobile, but the charger we are using the additional. Okay, we are connecting externally. that is called as the onboard chargers. But in the case of onboard chargers, what the charger permanently placed inside the vehicle. Only we are connecting the cable. Only we are connecting the cable. Clear? So that is called as the onboard chargers as well as off-board chargers. Okay. Battery chargers can be implemented or can be placed inside the vehicle is called as onboard. Okay. And which is used outside of the vehicle, that is called as off-board chargers. Okay. And next, the onboard chargers can be used only for level 1 and level 2 chargers. Onboard chargers can be used for level 1 and level 2 chargers. What is level 1 and what is level 2? We will see the next. Okay. Generally, the chargers have been classified into three types: level 1, level 2, and level 3. Depends upon the time of the charging. Depends upon the time of the charging. Okay, and voltage levels depends upon the voltage levels and time of the charging. The charger is have been classified into three types: level 1, level 2, and level 3. We will see the later. Okay, they usually have a unidirectional power transfer. They usually unidirectional power transfer capability. Just wait. In some case, the configuration a bidirectional power transfer can be achieved. Okay, let's see the figure here. um, the figure is visible, all of you?
Yes, sir.
Okay. uh, can you see in this diagram, we can see the two types of chargers here: onboard chargers and offboard chargers. Onboard charger, and this is the offboard chargers. Clear? This is the offboard chargers and this is the onboard chargers. So here, this onboard chargers is permanently placed inside of the vehicle. Inside of the vehicle. This offboard chargers we are using the additional. Okay. See, let's first one, onboard charger. It is a two-stage of conversion. Okay. Here, we can use this charger at home places or public places or working places. Clear? घर पे कौन सा सप्लाई रहता है? सिंगल फेस एसी. Is it clear? Okay. Here we are taking the AC supply and this AC is converted into the DC. Okay, this AC is converted into the DC because for charging the battery we need DC. So that's why we need to convert the AC into DC. AC into the DC. And if any voltage distortions are occurs or any ripples are present in the supply system, okay, so that can be removed by using the one capacitor. Okay, this capacitor is connected across the DC link. This capacitor is connected across the DC link. Okay, and this converter is converted from AC to DC, and the ripples are removed by using the capacitor, and this DC is given to the DC to DC converter. DC to DC converter, and this DC is given to the battery. This DC is given to the battery. It is clear? This is the line of the diagram. Are you get the point? First, we are connecting the plug to the home or house. Okay, and here the charger is inbuilt in the inside of the vehicle, and this charger is having two-stage energy conversion. This charger is two-stage energy conversion. First AC to DC. Okay, and here across the DC link, we are connected one capacitor for adding the some voltage or for storing the some energy and so on, etc. Means we can say for removing the ripples in the DC system, DC voltage levels. Okay, and this DC is given to the DC to DC converter, DC to DC converter, and the output of the DC to DC converter is connected to the battery terminals. The output of the DC to DC converter is connected to the battery terminals. Clear? So now the energy is stored in the battery. Now energy is stored in the battery. Next, when the battery is fully charged, okay, fully charged, or whenever we would like to take the supply from the battery, whenever we would like to take the energy from the battery, and then this DC, this battery is act as a supply now. This batteries act as a supply, and now this converter is act as a still chopper, DC to DC converter. Chopper is nothing but DC to DC converter, and this DC is connected to the across these lines. One terminal is connected to this point, another terminal is connected to this point. Clear? And then this here we are getting the DC, and this DC is converted to the AC using the inverter. This DC is converted to the AC, okay, using this inverter circuit. And then whenever we are converting the AC, and then we can give the this AC to the electrical motor. Okay, then we can give the this AC to the electrical motor. Clear? And whenever we are giving the AC supply to the electrical motor, and it will start. Okay, when the electrical motor starts, the vehicle is also starts to move in a particular direction. The vehicle is also moves in a particular direction. Clear? When the electric motor is getting the supply. This is the simple power flow diagram. Okay, I will explain you. The charger is connected to the home or house, and the charger is having two-stage energy conversion. Okay, the charger is designed by the two-stage energy conversion. First is AC to DC, because at home we are getting the AC. This AC is converted to DC. Okay, and this DC is given to the DC to DC converter, and this output of the DC to DC converter is given to the battery terminals. Battery terminals. Now the power is flows in this direction. Now the power flows in this direction. Okay. Now whenever we would like to give the supply to the electrical motor through the battery, so now the power will flow through this direction. Means this is the bidirectional power flows. Okay, this is the bidirectional power flow. This is the bidirectional converter. This is the unidirectional converter. This is the unidirectional converter. Clear? Next, upward chargers.
Excuse me, sir.
Yes.
Sir, Komal Khilari wants to join the lecture. She got call from college, so she had left the lecture.
Uh, okay, just wait. I will add, because once I will start at the full screen, it is not visible. That's the problem.
Okay, sir.
Okay, I will add. Okay, I added to all.
Okay, sir.
Thank you, thank you. Okay, this is the simple information regarding the onboard chargers. Okay, and next, offboard chargers. What is the power flow? Power flow of the offboard chargers. Generally, these offboard chargers directly connect to the grid. Directly connect to the grid. High voltage levels. Okay. Generally, the onboard chargers are working with low voltage levels. Generally, 110 or 240 volts. Okay. But in the case of, again, someone is going to join. Okay, offboard chargers with the students are joining. Okay, these outboard chargers are operated at with a high voltage levels. Okay, these outboard chargers are directly connected to the grid, directly connected to the grid, like a charging stations. Okay, so this is also two-stage energy conversion. This outboard charger also designed with the help of two-stage energy conversion. So from grid also we are getting the AC. Okay, but to charge the batteries we need DC supply. To charge the battery we need DC supply. Clear? So we have to convert from AC to DC. Okay, so if any ripples are present in the DC voltage levels, so that can be removed by using the capacitor. Okay, and this constant DC is given to the DC to DC converter for voltage control levels. Okay, this DC output of this DC to DC converter is given to the is given connected to the battery terminals. Is connected to the battery terminals through the some cables and so on, etc. Okay, so this is the simple information regarding the offboard chargers and onboard chargers. Clear? And this through the offboard chargers, we are taking the energy from the battery and through this converter. Through this converter, clear? DC to DC converter, and again is given to this DC terminals, and this DC is converted to the AC, and this AC is given to the electrical motor. When the supply is given to the electrical motor, the motor will start as well as vehicle is also moves. Clear? This is the simple circuit diagram of the onboard chargers and offboard chargers. The power flow levels of the onboard and offboard chargers. Okay, so onboard chargers are typically composed by two stages: front end and AC to DC stage and back end DC to DC stage. Like already we have uh, explained, this is the front end side and this is the back end side, DC to DC, and front end side converter is AC to DC. Okay, the front end rectifier usually contains boost power factor correction. Okay, so means we are using the capacitor here. So by connecting the capacitor across the DC terminals, we can improve the power factor level also. We can improve the power factor also. Okay, next. The rectifier stage can be performed by a half bridge or full bridge or multi-level diode bridge. Half bridge rectifier is less expensive since it contains less number of diodes or switches. Full bridge rectifier is more complex, but its components are subjected to the lower stresses. So what is the meaning of this point? See here. Here the front end converter, okay, that is the AC to DC converter. This is called as the rectifier. Okay, this rectifier may be a half wave rectifier or full wave rectifier or three phase half wave rectifier, full wave rectifier. It is clear? Or diode rectifier also. Clear? So means that is depends upon the voltage or power levels, which is suitable for this case. Or if a small power applications, we can design the half wave rectifier. If a high power application, we can design the medium power application. We can design the full wave rectifier. Clear? Like this same way. And also we can use the diode rectifier. Diode is the uncontrolled device. The power is not controlled, but energy conversion will be taken AC to DC. Here we can control the power using the DC to DC converter. Clear? Okay, full bridge rectifier with conventional power factor correction boost converter. See here, this is the AC to DC converter. Rectifier can be designed by using diodes like this. Okay, here the supply voltage AC. By using this converter diode rectifier, we can convert the DC. Clear? Okay, this DC is given to the load. Load is nothing but here battery. Okay, battery. We can store the energy in the battery. Next, off-board chargers. Level 3 charger, because of their rating powers, are usually installed outside the vehicle, that is called as onboard. So generally I have already explained, onboard charger is nothing but the charger can be used in the outside of the vehicle, and it is used in the high power levels, okay, high voltage levels, directly connected to the grid, directly connected to the grid. Since it is mandatory to guarantee galvanic isolation between the ACs, AC supply circuit and the DC output circuit according to the IEC EN 6185123 standard. This is the paper. Okay, in this only isolated onboard chargers have been presented. So if you go through if you want to reference, you can go through this paper. So you can get the more details about the onboard chargers. Clear? The onboard charging system is most commonly composed of two stages: a grid-phasing AC to DC converter and DC to DC converter. So generally, we have explained onboard charge is also two-stage energy conversion, AC to DC energy conversion at the grid side. And next, DC to DC energy conversion is taken at the battery's terminal side. Clear? The based on the converter topology, both these stages can allow the unidirectional or bidirectional power flow. So depends upon the our requirement. Depends upon the requirement and the designing of the charger. So this charger can allow the power flow in both direction, from vehicle to grid as grid to vehicle. Clear? Next, bidirectional AC to DC converter. Just I have given the simple example. Bidirectional AC to DC converter. One of the most widely used bidirectional AC to DC converter is the three-phase LCL active filter. Three-phase LCL. LCL is nothing but L is nothing but inductive, C is nothing but capacitive, and L is nothing but inductive. LCL filter. Okay, LCL filter. That's why they have given name for this LCL active rectifier. LCL active rectifier. This is act as a filter circuit. If any distortions are present in the current waveform, then these inductors will can remove these distortions in the current waveform. If any voltage levels or distortions occur in the system, so this capacitor will remove the voltage distortions levels. Okay, this circuit can be called as a filter circuit. Simply, this circuit can be called as a filtering circuit. Okay, so this constant supply is given to the rectifier circuit. This constant supply is given to the rectifier circuit. Clear? And this rectifier is converted to the DC. Okay, converted to the DC across these terminals. Across these terminals. This is the DC terminals. Clear? So if you want to convert the DC to AC. So this DC is converted to the AC using this converter. So this rectifier is act as an inverter now. When the power is flows in this direction, when the power flows in this direction, this rectifier is act as an inverter. So and then is converted to the AC, and this AC is given to the grid. Clear? This is the bidirectional AC to DC converter or DC to AC converter. Okay, one more example, a unidirectional AC-DC converter. The most common unidirectional AC-DC converter used onboard charging system is the Venena rectifier. Its name is Venena rectifier. It has advantages such as low voltage stress on each switch and high efficiency. Means here what we have done here, what we did here, here we are using the number of devices. Okay, in rectifier circuit or converter circuit, by increasing the number of devices, then what will happening? The voltage stresses will be decreased on each device. The voltage stresses will be decreased in each device. Clear? So that is one of the main benefit of this converter circuit. So in case, for example, we are using the only one we are using the converter, and in that converter only one device is present. Okay, only one device is present. तो एक ही डिवाइस प्रेजेंट होता है उसका ऊपर ज़्यादा वोल्टेज स्ट्रेस रहेगा बिकॉज ओनली वन डिवाइस इज कैपेबल इन द वन डिवाइस इज एबल टू कैपेबल द टोटल पावर सो वोल्टेज स्ट्रेस ज़्यादा रहेगा इन केस द रेक्टिफायर इज डिजाइन बाय द नंबर ऑफ डिवाइसेस okay so somewhat the voltage stresses will be decreased because the number of devices is increased means the voltage level will be distributed across each devices. It is clear? So like this, that is the one of the main advantage of this unidirectional AC to DC converter. This is the simple block diagram of the AC and DC charging structure. AC and DC charging structure. Okay, this is the onboard chargers. Is it visible? Screen is visible, all of you?
Yes, sir.
Yes,
Okay.
sir.
Are you getting the concept?
Yes.
Is there any problem?
No, sir.
Okay. This is the onboard chargers. Clear? Already we have explained, but this is the simple block diagram. From directly home or offices, we can charge the vehicle. Okay, this is the small voltage levels, 110 or 230 volts. Means 230 volts we can get from home also, at office places also, working places also. Okay, so and then this onboard charger is given to the battery. Okay, this is the battery management system, and then battery. And then from this battery we can give the supply, we can give the energy to the electrical motor, and then by running the by starting the electrical motor, the vehicle can be starts. Okay, this is the outboard chargers. The outboard charger is placed outside of the vehicle. Okay, outside of the vehicle, this outboard charger is operated with a high voltage levels, with high voltage levels. So that's why outboard chargers cannot be used at the house or office workplaces, etc., because that much of voltage levels will not be available in the houses or homes. Okay, next, this is the charging station levels: level 1, level 2, and level 3. This is the DC fast charger is nothing but level 3. Clear? Level 1 का voltage capacity how much? 110 volts. Okay, voltage capacity is 110 volts, and charging power is 1.4 kilowatt. Range per minute of charge means, if you charge for 1 minute, if you charge 1 minute using level 1 charger, so we can travel the 0.082 miles. 0.082 miles is nothing but approximate 1 kilometer. If you charge the 1 minute, then we can travel the distance 1 kilometer. Clear? See, if you charge it 2143 minutes, 2143 minutes. So how much time this one? Can you convert in hours? 2143 minutes. So approx 35 hours, I think. Is it right? Is it right? Approx 35 hours.
Yes, sir.
Okay. So if we charge the 35 hours, then we can travel the distance approx 200 miles. 200 miles. 200 miles is nothing but approx 320 kilometers, etc. 1 mile is equal to 1.8 kilometers. Clear? So this level 1 charger mostly can be used at the home, etc. घर पे use कर सकते हैं अपन. So level 2 charger what will be the voltage capacity of this charger? Level 2 charger 220 volts. 220 volts. Charge power kilowatt 7.2 kilowatt. Charge power in kilowatt 7.2 kilowatt. Okay, range per 1 minute of charge. If you charge 1 minute of this level using level 2 charger, so we can travel the 0.42 miles. 0.042 miles. So you can convert into the kilometers. 1 mile is equal to 1.8 kilometers. Clear? So if you charge 417 minutes, if we charge 417 minutes, then we can travel the 200 miles. We can travel the 200 miles. Means this is the charging time is decreased from level 1 to level 2. Okay, please get the difference between these 2 points. So by increasing the voltage levels, the charging is also increasing. The charging time is also decreasing. Okay, only if we charge the 417 minutes, so we can travel the 200 miles. So this charger can be connected at the house or work public locations and so on, etc. Okay, house or working places, like working places is nothing but office works. Okay, at office works also we can charge these vehicles using the level 2 charger batteries. Next, DC fast charger. This is the level 3 DC fast charger. The voltage levels of this DC fast charger or level 3 charger is 480 volts. 480 volts, clear? And the charge power is 50 kilowatt. 50 kilowatt. And if we put the 1 minute charge, so we can travel the 2.92 miles. 2.92 miles. 2.92 miles is nothing but approx 5 kilometers. Approx 5 kilometers. So only 1 minute charge रखेंगे तो कितना travel कर सकते हैं अपन? We can travel the 5 kilometers. So if we charge the 60 minutes, okay, if we charge for 1 hour, so we can travel the 200 miles, means 300 kilometers and so on, approximate. Okay, and this DC fast charger can be used at highway low corridors, means charging stations का use करना पड़ेगा. Okay, only at charging stations, highway corridors, we can use these level 3 chargers only. Okay, at home or office places, we cannot use these chargers because these voltage levels are not present in the homes or office works. At homes only, we can get the up to 200 to 230 volts, but it requires 480 volts. It requires 480 volts. So 480 volts के लिए we have to design the some charging station. Okay. Next, Tesla supercharger. So this is the latest Tesla supercharger. This voltage level is also 480 volts, and the charge power is difference 50 kilowatt to 140 kilowatt. So here, if we put 1 minute charge of this using the Tesla supercharger, so we can travel the approx 12 kilometers. Approx 12 kilometers. So if we put 21 minutes, 20 to 25 minutes charging, so we can travel the 200 miles. Okay, we can travel the 300 kilometers approximate. Okay, this is also can be used at the charging stations, that is the highway corridors or public locations on etc. Clear? This is a very very important point. Please remember. Did you get this table? The concept of this table? Anyone, please?
Yes, sir.
Okay. So the charging levels, the chargers can be have been designed three types: level 1, level 2, and level 3, based on the voltage levels and charging time. Based on the voltage levels and charging times, the chargers have been classified into three types: level 1 charger, level 2 charger, DC fast charger, and latest charger is the Tesla supercharger. Clear? Next. Okay, these are the future upcoming charging infrastructure in our India. Okay, so like a petrol pumps, we can design the charging stations also. Like a petrol pump, we can develop the charging infrastructure like this. Clear? And also we can use the solar panels. Okay, by using the solar panels, we can develop the or we can design the charging station also. It is clear. Next, at highways also we can design the charging infrastructure like this. And it at home places means घर पे अपन charge भी कर सकते हैं. These are the charging infrastructure in coming days in our India. Okay, the Tata company is going to put the infrastructure of charging infrastructure across the India. Tata, BHL, and so on, etc. Okay, they are trying to develop the charging infrastructure across the India. Okay, it is in planning. Okay, due to there is no charging infrastructure, the electric vehicle not coming to the market. That is one of the main reason. Okay, otherwise if the charging infrastructure is developed in India, so the electrical vehicles come into the market and it will be popular and it will be increased. It is clear. Next, by using the wind power. Okay, by using the wind turbine also we can design the charging infrastructure for the way charging the vehicles, electric vehicles. Next, what is this? Can you tell anyone? This is also charging. This is also charging station. So, but what it is? It is without cable connection. For example, if you know the transformer, so transformer is having the two windings, primary winding and secondary winding, but there is no electrical connection between the primary winding and secondary winding. It is clear. There is no electrical connection between the primary winding and secondary winding, but the power is transfer from primary winding to the secondary winding. One minute. Okay, so see here, this type of charging structure is also going to develop India. What is the concept of this charging structure? So, for example, if you take the transformer is having two windings, primary winding and secondary winding. But there is no electrical connection between the primary winding and secondary winding. But the power transfer from primary winding to secondary winding, from primary circuit to the secondary circuit. It means the transformer will work on the based on the principle of mutual induction. So like the same here also, so one coil is placed in at the ground level. Okay, one coil is placed at the ground level, and another coil is placed at the car. One coil is placed at the ground and one coil is placed inside the car. So when this car is comes and stand exactly at this primary coil. Okay, when the primary coil and secondary coils are very nearly distance. Okay, then the primary coil is already energized by giving the external supply. So the due to this mutual induction principle, the current is flowing through the secondary coil also. Through this secondary coil, so the battery can be charged. Through the secondary coil, the battery can be charged. Clear? This is also one type of charging infrastructure. सो हियर ओनली अपन के क्या करना है, कार को लेकर जस्ट अक्रॉस इस कॉइल का अक्रॉस खड़ा करना, स्टैंड करना है. Okay, so automatically based on the mutual induction principle, so the current will flow from this primary coil to the secondary coil which is placed inside the car. Okay, so through this by using the secondary coils we can charge the batteries. Clear? So this is the one type of charging. Okay, these are the future upcoming charging infrastructure in India. Okay, charging time generally can be defined as battery capacity kilowatt hour upon by charging power. Battery capacity, the ratio between the battery capacity kilowatt hour upon by charging power kilowatt. The, depends upon the battery capacity, power density, and charging power. The larger the capacity, the more charge the battery can hold, analogous to the size of the fuel tank. Higher power density allows to the battery to accept more or charge per unit time. The size of the tank opening. Higher charging power supplies more energy per unit time. Okay, means what we can say here, the charging time is depends upon the battery capacity as well as power density. Clear? The usable battery capacity of a first generation of electric vehicles such as original Nissan Leaf was about 20 kilowatt hour, giving it a range of about 100 miles, means 160 kilometers. Tesla was the first company to introduce the longer range vehicles. Okay, Tesla was the first company to introduce the longer range vehicles, initially releasing their models as Tesla S model with a battery capacity of 440 kilowatt hour, 60 kilowatt hour, and 85 kilowatt hour, with latter lasting for about 480 kilometers, 300 miles approximate. plug-in hybrid vehicles typically have capacity of roughly 3 to 20 kilowatt hour, lasting 20 to 80 kilometers, okay, or 15 to 80, 50 miles. Means what we can say here, the Tesla S models was the first company to develop the uh, electric vehicle to travel the distance approximate 100 miles. 100 miles means 160 kilometers. Clear? As well as they developed the battery capacities 20 kilowatt hour to 85 kilowatt hours. So it can be able to travel up to 480 kilometers once we charged. Clear? So like the same AC to DC conversion, already we have been discussing this AC to DC conversion in the charging infrastructure, charger circuit. Okay, safety. What is the charging stations are usually accessible to multiple electric vehicles and are equipped with the current or connection sensing the mechanisms to disconnect the power when the electric vehicle is not charging. Okay, there are two main types of safety sensors. Current sensor monitor power consumed and maintain the connection only while the demand is within a predetermined range. So here, while designing the charging infrastructure, okay, charging station, so we have to remember safety precautions. Okay, we have to remember safety precautions. We have to use some sensors. Okay, whenever the high current is flowing the system, so immediately the sensor will give the indications in order to isolate the circuit. In order to isolate the circuit, isolate means disconnect the circuit. Okay, if such a high current is flowing through the circuit, then what will happening, the charging station can be damaged or the battery also can be damaged. So that's why we have to use some sensors, current sensors, whenever the high current is flowing through the circuit. So immediately the circuit should be isolated means disconnected. Okay, so otherwise the charging station or battery can be damaged. Clear? And one more point we have to remember. So in one charging station, we are going to charge the number of vehicles. Okay, we are going to charge the number of vehicles at a time. So two vehicles, more than two, three vehicles, four vehicles, or at a time 10 vehicles also we are going to charge. Clear? So if any one fault is occur at any point, so then what will happening, it will be disturbed to other charging cars also, because all these are connected to the same line, so what will happening, uh, the other cars also will not be charged if any one circuit is fault. If any one circuit is fault, the other electric cars are also not charged. So that's why we have to remember while designing the charging station. So whenever the fault is occur at the one point, immediately that section should be disconnected. Immediately that section should be disconnected in such a way that will not be affected to the other sections which we are going to charge in that station. क्लियर? सो आर यू गेट द पॉइंट? अगर एक चार्जिंग स्टेशन में अपन 10-15 व्हीकल्स एट ए टाइम चार्जिंग कर सकते हैं, ओके, एट ए टाइम 10-15 चार्ज व्हीकल्स चार्ज करते हैं, तो कोई भी एक पॉइंट पे अगर कोई फॉल्ट अकर हो गया तो दूसरे 10 सेक्शन में डिस्टर्ब हो जाएगा. ओके, सो दैट्स वाई इट शुड नॉट हैपन लाइक दैट. सो वेन एवर द कौन सा सेक्शन में फॉल्ट अकर हो गया, दैट फॉल्ट शुड बी डिस्कनेक्टेड. कौन सा सेक्शन में फॉल्ट अक्कर हो गया तो वही फॉल्ट को डिस्कनेक्ट होना चाहिए. ओके, रिमेनिंग सेक्शंस को कंटिन्यू चार्जिंग होना चाहिए. क्लियर? अगर सभी डिस्टर्ब हो गए तो क्या हो जाएगा, तो सारे इट विल टाइम ज़्यादा लगेगा, फिर उसको मेंटेन कर उसका मॉडि क्या बोलते हैं, फॉल्ट को डिटेक्ट करना है, फिर मॉडिफाई करने का है, फिर इट विल टेक मोर टाइम. It is clear? These are the two main important points. Okay, first one is that we have to use the safety sensors, that is the current sensors, voltage sensors, whatever. Whenever the high current is flowing through the circuit, that circuit should be isolated. Okay, and whenever the one point or one section is disturbed, one section is fault occur, that section should be isolated, should be disconnected. Clear? These are the some safety precautions we have to remember while designing the charging infrastructure. Clear? So one more charging station is there. What is that? Battery swap. Battery swap is nothing but, can anybody say? Battery swap is nothing but, can anybody say? Are you there in online, please? All of you
Yes,
there?
sir.
What is battery swap? फॉर एग्जाम्पल, अगर अपन एक मोबाइल बैटरी डैमेज हो गए, मोबाइल इज नाइस, मोबाइल कंडीशन इज वेरी गुड, बट बैटरी डैमेज है, सो व्हाट वी विल डू? सो वी विल गो फॉर द मोबाइल शॉप एंड वी विल चेंज द बैटरी. इज इट क्लियर?
Yes,
Yes,
sir.
sir.
ओके, लाइक दिस सेम वे. तो क्या होता है, एक ऐसे चार्जिंग स्टेशन डेवलप करते हैं, ऑलरेडी चार्जिंग फुल, ऑलरेडी जो चार्ज फुल रखे वाले बैटरीज रहते उधर. जैसे कार व्हीकल जाने का है, तुरंत अपना कार का बैटरी निकालने का, वो बैटरी डालने का है. जो फुल चार्ज बैटरी रखा है स्टेशन पे, तो वो बैटरी रिप्लेस करने का है. इसमें क्या होता है, चार्जिंग टाइम कम हो जाता है ना. No need to spend the more time to for charging the vehicle at the charging station. 1 hour, 30 minutes, 1.5 hours, and so on, etc. Just replacing the battery with empty battery is replaced by the full charging battery. This is also possible, na?
Yes, sir.
Okay, means this type of charging infrastructure is called as a battery swap charging station. Battery swap charging station. Okay, इसमें क्या होता है, टाइम सेव होता है. जस्ट अपना व्हीकल का बैटरी निकालो, जो डिस्चार्ज हुआ बैटरी, और जो ऑलरेडी उस स्टेशन पे ऑलरेडी फुल चार्जिंग वाला बैटरीज रहता है, स्टोर रहता है, तो वो बैटरीज रिप्लेस करो, तो इमीडिएटली विद इन 3 to 5 minutes we can move from that place. It is clear. This is also this is also research is going on this battery swap charging stations also. Clear? So this is a simple information regarding about the chargers and charging stations. Is it clear? I think did you get the concept?
Yes, sir.
Yes, sir.
All of you, please. Okay, so just wait, I will take the attendance. We have only 5 minutes.